There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radium, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
All right, we have boiling water, water near the boiling point. And we're going to put some para-dichlorobenzene crystals in a test tube and put them in the test tube with the para-dichlorobenzene in the boiling water. Here's the para-dichlorobenzene. This is not boiling water, but it was boiling a second ago, so it's well toward 100 degrees. And let's see what happens. If you look at the crystals, you can see that they're starting to melt. So this is an easy demonstration to show melting. They melt at about 53 degrees Celsius. And the temperature is well above that temperature. Yeah. Takes a while for them to all melt.
Maybe we'll speed it part up. We can always split it.
Okay, now once they all melt, now, try not to shake. We can smell the vapors of the para-dichlorobenzene. We're doing this outside to have a lot of ventilation. The last crystal is about to melt. Okay, now I'm going to take it out and let it cool. Take a little while, but it should recrystallize. We're going to show the same para-dichlorobenzene or mothball crystals now dissolving. I'm going to put some acetone in, pour it in carefully, and we're doing this outside because they're both kind of dangerous
Inside.
to use inside or smelly.
Inside and
Okay, so I used acetone, and now I'm going to cap the acetone. There's a little bit of colored stuff at the bottom. It was due to some other experiment I did recently. But you can see it's starting to dissolve. You can see the little striations as it dissolves. And this is dissolving. This is all occurring at room temperature. Whereas melting, we had to heat it up to get it to melt. So this is dissolving.